In the last episode, you were witnesses of the birth of this HHO electrolyzer, as well as a couple of unsuccessful attempts to weld it so that it would not leak. And in the end, me abandoning Mark 1. Now, this experience was kind of humbling, I'm not gonna lie. And so I faced the challenge of coming up with at least something that works, right? And so that's why I decided to come up with Mark II. You might say, well, Mark II is kind of simpler than Mark 1. And yes, indeed, it does not involve welding. In fact, it does, but not for a weld that should seal. And so what Mark II is essentially one of the classic designs you can see on YouTube with a glass jar where I put two threaded rods through it as electrodes, sealing them with grommets and having an extra grommet for the hose as the HHO exhaust, so to say, while having a second glass jar filled with water, and that being a flashback arrestor that in case I decided to actually burn the hydrogen on the or HHO on the other end of the hose, if it caught fire, which it does usually, it wouldn't travel all the way to the electrolyzer, but it would actually get extinguished in the flashback arrestor. So it's really as simple as that. Let's have a look at what I managed to put together. This is the part that requires welding. I'm welding a 4mm threaded rod, I believe that is, to the thicker ones so that I can then easily attach my electrodes. When I come to think of it from my today's perspective, it might have actually been God's protection not letting me finish that Mark I cylindric design. Why? Three reasons. Well, for one, it's not see-through, which wouldn't be the biggest issue, but I couldn't see what's inside, what's going on there. For two, I didn't have all the washers made of stainless steel. Some of them were really zinced, which would probably cause some, gunk going on there. Who knows? But more importantly, or most importantly, actually, what I'm trying to do next with the electrolyzer might have been pretty dangerous, provided I was using Mark 1. So let's see what I did. Okay, the bending radius here is kind of wobbly, but the clamp fixes it, believe it or not. When you look up electrolyzers online, you will probably get to the information that they run at about 1.5 volts. Well, it doesn't really say what kind of design it is, and it truly does not run on 1.5 volts with this design. Then there are YouTubers who have power rated maxing out linear power supplies, those that are capped at 30 volts, 10 amps, which was indeed effective. They were able to get some production from there. But the thing is, I didn't have one. You might have guessed right. It's the welder that's gonna power this thing up. I'm using the MMA mode, plugging each electrode or the electrode holder essentially and a clamp on both the electrodes. And with this welder, the lowest current setting I'm able to get is 30 amps. There is no voltage regulation on the MMA mode. Let's see how that runs. Now, at this point in time, we haven't added any KOH yet, so this is plain distilled water. And let's see how that runs. I didn't see any bubbles here. I did see some bubbles here. What I expected was with this kind of high current to be passing through the electrolyzer, at least some production of HHO, which would manifest in seeing actually bubbles coming out of the negative electrodes, especially. But I didn't see much, if any. And so this really points out to the fact that plain distilled water is not really capable of doing electrolysis alone. What you need to do is add something which has ions, let's say table salt or NaCl would be probably the easiest solution most people would look for. But in this case, I ordered KOH, and we're gonna see how it runs with KOH. Great. So we've tried that the electrolysis does not occur with just distilled water. So that's why I have potassium hydroxide here. And what we're going to try to do is add 10% at first of mass, try it with the 30 amps of current, and if it's not feasible, then we can add some more. So first I'm going to measure how much water I actually have here. I think it's going to be about half a liter. So good. So I'll add to half a liter. Okay, half a liter of water, distilled water. And so if we want to have a 10% solution of potassium hydroxide, we're gonna need to add 50 grams, assuming that 1 liter is 1 kilogram, which it might be. It's distilled. Yep. We're gonna use gloves, and we're gonna also use goggles. I mean, let's do it the proper way. And let's 50 grams. Electrolyzer. All right, now let's blend those two real well. Can use this tube. That seems about right. Fine. So now we've got what seems to be a 10% solution of potassium hydroxide here. We've got normal water here, and we're gonna attach our tube where HHO should flow. And now we've got our electrodes here. Again, they are almost touching each other, but not touching each other. Sealing, although I put some silicone in there, it's just not enough. Now we're at 65 amps, and we're getting some HHO here. Just worried a little about the bubbles. So I'm gonna lower this. Okay, lowest setting 27 amps. We're seeing plenty of bubbles here, but we don't see much HHO going through here. So let's add some more silicone here. Fine. And now we've got quite some production here, actually. That's good. Okay, got a new setup here. Let's connect these again. After all, I fixed up some of the issues, and the things that were the most challenging were actually how to seal the grommets, even though there was a rubber ring and I used some silicone, it still wasn't enough in some cases. I guess probably the high current was causing too much gas buildup and too much pressure onto that. So it's not really great. And one other place where the gas might have been leaking was actually the lid. So after all of this, I actually taped it with an air stop tape, which should seal somehow, or at least I did try that. And I fixed up the bending radius, but that's basically where I could get with this design. I added some KOH in the end. It was a 30% solution. So we have seen that this indeed does work. It did produce HHO. So we can call it a success. But am I happy with this one? I would have imagined it to be a little more efficient. Great! Now that we've seen Mark 1 and Mark 2, where Mark 2 actually did produce some HHO, I want to make it more efficient. In fact, that's why I'm here. So, there's Mark 3. Now, to quickly describe this design, it's essentially a glass jar, but a big one, and the electrodes are essentially stainless steel, but this time they're bigger, they're hollow sections, and they should have more surface area. And the fact that they're hollow means that we might be actually able to get oxygen on the positive electrode and hydrogen on the negative if everything goes well. Now, this cannot really compare to the FAAM membrane design because the membrane is actually the thing that prevents any molecules of gas passing through, but this is as close as we can get without it. In fact, actually incorporating the membrane into this design probably would not be possible, as sealing out on the edges of the glass jar would probably pose a huge challenge, if not impossible. So here we've got the hollow sections as electrodes, and I sustained that idea from Mark 1 essentially, which was that actually the whole thing is going to be held in kind of a cage with threaded rods pressing down. The reason being is that we want the lid to be actually sealed. Now, initially I thought that I would just cut out a circular lid out of wood and I would push it onto it with some sealing, but it's very difficult to cut out a precise lid out of wood for me, and to find actually a sealing that fits it. Instead, I thought this might be an easier solution because I can just place the board over it, put some butyl rubber sealing on the perimeter and seal it with pressure. So that's basically what this idea is. We should be getting more surface area of the electrodes, therefore a higher efficiency. Now, I haven't yet put the concrete dimensions there, but this is approximately what it should look like. So, my question is, should I focus my energy on making this happen? Let me know if you're interested in seeing Mark III's birth